Hello student, welcome to Study Circle YouTube channel. First of all, thanks to all those students who had liked, subscribed and gave comment to the last videos of gravitation chapter. And it is requested to other students, please subscribe, like our channel and also press the bell icon so that you will get the notification of our upcoming videos. Now today in this video we will discuss another important chapter of physics for standard 9, that is work, energy and power. So we have to discuss here work, energy and power. So first of all start with work. As you know, work, जैसे कि हम लोग जानते हैं काम कोई कहीं काम करना, that is said to be work. But in physics, physical meaning of work is completely different what it means in our daily life. For example, a student learning a lesson or a man is standing with some load kept on his head. According to physics, both are doing no work. Do you believe that? Even I am teaching you, and according to physics, I am doing no work here. Now, if I am standing and simply teaching you, but उसको physics काम नहीं मानता है. But अगर हम एक डंडा उठा ले और मारने लगे स्टूडेंट्स को, तो फिजिक्स के हिसाब से वो काम है. बट हम ऐसे यहाँ पे खड़े होकर अगर पढ़ा ले, तो according to physics, I am doing no work. Then what is work? According to physics, work is said to be done if you apply a force on a body and if the body is displaced, then work is said to be done. Means, suppose here it is a body, if certain force is acting on the body, as a result of that force, body come in this position. If it is the displacement of the body from here to here, S is the displacement, then physics इसको काम मानता है. मतलब according to physics there are two conditions. When a force is acting on the object and object displaced from its position, then only we can say that work is done. So there are the different type of the works formula we have to read in this chapter. The first is the simple, when a force is acting on an object and if it displaces from its position, then the work is said to be done. For example, a bullock pulling a cart. The bullock is applying a force, as a result of that force, cart is moving. So we can say that work is done by the bullock. Okay, so that means not only if we are suppose applying the force and if there is no displacement, then work is not said to be done. Okay, so the first formula for the work done equals to the force that is acting on the body into the displacement by the body. That is the first formula for the work done. If the F force is acting on the body and if the body displaces, then work done is equals to force into displacement. Is it okay? And when a body do some work, then if a body suppose do some work, then equal amount of energy is consumed from the body. Matlab, for example, if I lift it, then I am doing some work. If I lift it, so if the 10 joule is work done, then 10 joule of energy is consumed. So what is unit of the work is same as the unit of energy, because whenever a body doing some work, an equal amount of energy is consumed from the body. So the unit of work done is here joule, which is same as the unit of energy, and 1 joule, if the 1 joule is work is done, that is equals to 1 Newton meter. Means if the 1 Newton force is acting on the body and suppose if it is displaced by 1 meter, then the 1 joule equals to 1 Newton meter. So that is the first formula for the work done when the body moves in the direction of applied force. In your syllabus there are 3 formulas you have to read for the work done, so that is the first formula. Second one, suppose if I am lifting somebody to a certain height, then also I am doing work because I am acting a force against the gravity. जितना इसको ग्रेविटी खींच रहा है उतना फोर्स हमको लगाना होगा तभी ये ऊपर जाएगा. So when I am lifting some objects to a certain height, that means I am doing work. How much work done? In that case, work done is equals to work done against gravity. Second one. That is work done against gravity is W equals to, we know that force into displacement. So when I am lifting an object, how much force I have to apply to overcome the gravitational force? जितना इस पे gravitational force लग रहा है उतना ही force हमको लगाना होगा, then it will go up, and that force is equals to the weight of the body, and weight equals to m into g. So that means the place of force m into g, and in the place of displacement, that is here height, so s is replaced by height. So that is work done against gravity is equals to mgh. That is the second formula for the work done. Unit will be remain same joule. Mass is in kg. It must be meter per second square. We know that, and height must be in meter. Then the unit of work will be in joule. So there are two cases of the work done. We have seen that when a body is moving in the direction of force, then work done equals to F into S. And when work done against gravity, work is done if certain body is lifted to a certain height body, then work done equals to mgh. The third case of work done, let us try to understand. Now continuing with the third case of work done, that is work done obliquely. In the first two cases we have discussed that when a force is acting in the direction of motion of the body, that is work done equals to F into S, and when work is done against gravity, so work done equals to mgh. Now the third case, that is the third case for the work done, that is work done obliquely. Work done obliquely means, try to understand, suppose it is a body, if the force is acting in this direction, but the displacement of the body is in this direction, then that is said to be the work done obliquely. जैसे कि हम लोग देखें, when a boy जो एक गाड़ी को खींचता रस्सी से, तो the direction जो था, it is in the other direction, but the body is moving in this directions. So same is here, the direction of force is in another direction, but the direction of motion is different. And if there is an angle between them, the direction of force and the direction of motion, that is, that angle if it is theta, then work done obliquely equals to W equals to F into S cos theta. When there is some angle between the direction of force and direction of the motion of the body, then that is said to be work done obliquely, and work done obliquely W equals to Fs cos theta. Cos theta is a trigonometric term here. Till now you have not learned about the trigonometry. So actually for different degree of angles, for different value of theta, cos theta has a different values. So the value of the cos theta will be given in your questions when you have to solve the numerical by this formula. Cos, for example, like if the theta is 30 degree, the cos theta value is root 3 by 2. If theta is 60 degree, so the value of cos theta is 1 by 2. So for different angle, cos theta has different value, and the value of cos theta will be given in the questions. Then we can calculate by this formula work done obliquely. Is it clear? These are the three cases of the work done. Now, the next nature of work done. First, work done positive. Work positive means if the direction of force and the direction of the motion displacement is same, then work is said to be done positive. Is it clear? Means जिस डायरेक्शन में फोर्स लग रहा है उसी डायरेक्शन में अगर बॉडी मूव कर रहा है देन वर्क डन, द वैल्यू ऑफ वर्क डन विल कम पॉजिटिव. सेकंड केस, जीरो वर्क डन. Suppose if the direction of force acting on the body in this direction, that is the direction of force, and the displacement in this, that means when the direction of force and the direction of motions of the body, if there is a perpendicular to each other, means if the angle between the direction of force and the direction of motion is 90 degree, then work done is said to be zero. For example, when a person kept some load in his head, so the force and it is moving is horizontally. So the work done by gravitation, the gravitational force is acting in this direction, but body is moving in that direction. So we can say that work is there zero due to the gravitational force. So when there is an angle between the direction of force and direction of motion is 90 degree, then work done is said to be zero. Third case of the work done, negative work. When the direction of the force is in this direction, but if the body displacement, the direction of the displacement in this, means when the displacement of the body or motion of the body in the opposite to the direction of force, then work done is said to be negative work. Like for example, if I lift it to a certain height, then the force that is of gravity that is acting on this body in this, but body is moving in the opposite direction to the gravitational force, then the work done by gravity is here negative. So that means when the direction of force and direction of motion of the body is same, work done is said to be positive. When the direction of force and direction of motion is perpendicular, work done is zero. And when the direction of force and direction of motion of the body is opposite to each other, then work done is negative. So that is about the work. Okay, I hope is it clear. So in the next part of the video, we will discuss the energy and power. Okay, thank you.